Have you ever stopped to think about how an AI learns to do something totally new? I'm not talking about memorizing a bunch of data, but actually learning a skill through trial and error, kind of like we do. Well, that's exactly what we're diving into today, the amazing world of deep reinforcement learning.
I mean, seriously, how does a robot learn to dance? It looks like magic, doesn't it? But here's the secret. There's no choreographer programming every single step. Instead, it's an AI learning from its own experience, figuring out which moves are smooth and which ones, well, aren't, all by itself. It's one of the coolest frontiers in AI right now. And trust me, this is not science fiction. This stuff is already out there making waves. Remember when AlphaGo made that Move 37 that just blew the minds of human Go masters? That was reinforcement learning. It's the same tech that lets robots learn tricky things like folding your laundry, and it's a huge part of what makes the powerful language models and image generators we use so good. It's even designing computer chips now. So, yeah, this isn't just a cool theory, it's actively changing the world as we speak. Okay, so to really get what makes reinforcement learning, or RL for short, so special, we need to see how it's different from the way most AI learns. The whole idea is about learning without a teacher constantly telling you what to do. So, what's the difference? Well, think about traditional supervised learning, like studying for a test, with the complete answer key right in front of you. You get thousands of examples, and for each one, you're told this is the right answer. But with reinforcement learning, there is no answer key. The AI has to learn by just trying things out, by interacting with its environment. And the feedback it gets is way more subtle. It's often just a good job or try again signal that might not even come until way later. The goal isn't just to get one answer right, it's to learn an entire behavior, a strategy that gets the best results over time. So, how does our AI learner, what we call the agent, decide what to do next? That's where something called the policy comes in. You can literally think of the policy as the agent's brain. It's basically its strategy guide. Under the hood, it's a neural network that looks at the situation and decides what action to take. And honestly, the entire goal of reinforcement learning is to find the best possible policy. To learn that policy, the agent has to understand the world it's in. And we can really think of this whole setup as a game with three simple fundamental rules. Rule number one is the state. This is just a snapshot of what the world looks like to the agent at this very moment. For our laundry folding robot, the state might be the live feed from its cameras, plus all the data about the exact position of its arm joints. It's everything it needs to know to make a decision. Now, based on that state, the agent has to make a choice. And that brings us to rule number two, the action. For our robot, an action is a specific command, like move joint number 3 to a 92-degree angle. It's how the agent actually interacts with and changes its world. And finally, we have the most important rule of all, the reward. This is the feedback. It's just a number that tells the agent if what it just did was good or bad. So for our robot, it might get a big fat 0 for every single move it makes, until finally it places the towel perfectly on the hook. And at that exact moment, it gets a reward of +1. That single number is the only thing guiding its entire learning process. And this all comes together in what we call the learning loop. It's this constant cycle. The agent sees the state of the world, uses its policy, its brain to take an action. It gets back a reward and sees the new state. And then, and this is the magic part, it updates its policy, tweaking its brain just a little bit to make it more likely to do things that led to good rewards in the past. Then it just repeats this, thousands, even millions of times. This simple loop lets an AI solve problems that are way too complex for any human to write code for by hand. So what's the ultimate goal of this endless loop? It's not about getting just one good reward. It's about becoming a master of the game and getting the highest score possible. The whole objective is to find a policy that racks up the highest total score, the biggest sum of rewards you can possibly get over an entire sequence of actions, what we call an episode. It's all about playing the long game, not just making one good move. But did you catch that one word in there, expected? Why the expected sum? Why not just the highest sum? Well, because reinforcement learning happens in the real world, and the real world is unpredictable. You can't guarantee you'll get the same result every single time. This unpredictability, or stochasticity, if you want to be fancy, comes from two places. First, the world itself can be random. A self-driving car can't perfectly predict what every other driver on the road is going to do. And second, the agent's own policy is often intentionally random, at least at first. It will sometimes try a totally weird move just to see what happens. We call this exploration, and it's absolutely crucial for discovering new and better ways of doing things.
So, to find that perfect policy in the middle of all this randomness, researchers have developed a whole playbook of different algorithms and strategies.
Now, we don't need to get lost in the weeds here, but the main thing to know is there are different ways to approach the problem. Some methods, like policy gradients, just try to directly improve the policy, kind of like a golfer practicing their swing over and over. Other methods try to figure out how valuable it is to be in any situation, more like a chess master looking at the board and evaluating who has the advantage. And some clever methods even try to build a little simulation of the world inside their head so they can plan ahead. It's a really rich and fascinating field. But all of these different strategies, they all come back to this one beautiful, incredibly powerful idea. Reinforcement learning makes it possible for an AI to learn wildly complex behaviors, starting from absolutely nothing, with only a simple goal to guide it. It is the ability to learn from its own experience in the world. And that brings us to the final and most mind-blowing question. We saw it with AlphaGo, an AI that discovered strategies no human had ever even thought of in thousands of years. So if AI can do that in a game, what happens when we point this incredible learning tool at some of our biggest challenges, like discovering new medicines or designing fusion reactors? What other fundamental problems could it solve that we can't even imagine yet? The potential is just staggering.